In our experiment, a heavy and light toy car will fall down a curved ramp and differences in acceleration and force will be compared. In regards to this, we hypothesize that both of the tested cars will consist of the same final velocities after sliding down a ramp with a curve. The physics concept used in the hypothesis of this experiment was the conservation of energy, in which the initial and final potential and kinetic velocities are equal. The conservation of energy concept was important to consider when determining the final velocity of the objects instead of the acceleration force due to the curve rather than flat track. With this being said, energy conversion allowed for the conclusion that there is a loss of energy during the decline of the racetrack, which allows for the final and initial energy to be calculated the same. This allows for the final speed to be calculated as square root of 2gh. Using specific forms of these quantities, 1/2 mvi squared plus mghi equals 1/2 mvf squared plus mghf is produced. Within this situation, some quantities are 0 and 0 plus mghi equals 1/2 mvf squared plus 0, which may be produced, and the next steps would be to solve for the final speed. The velocity versus time graphs will provide the x and y components of the system, which will help calculate and compare the predicted and observed final velocities. We can conclude that the potential energy, mgh, is equal to the kinetic energy, 1/2 mv squared. This demonstrates the principle of the conservation of energy, or ui plus ki equals uf plus kf, where u represents the potential energy and k represents the kinetic energy, and subscripts I and f represent initial and final values respectively. The aforementioned equation can be simplified to ei equals ef, where e represents energy and subscripts I and f represent initial and final values respectively. Because the masses in this equation cancel, we will only be considering the difference between the top and bottom positions, which is y initial and y final respectively. Thus, we must determine the final velocity of the toy cars, because the mass differences will not affect the magnitude and direction due to the curve of the track. Overall, the conservation of energy is demonstrated with this idea that the initial and final potential kinetic energy are equal to each other. For our predictions, we believe that mass will influence the final velocity and that the lighter car will have a greater velocity. Using the equation final velocity equals the square root of 2 times gh, we predict that the final velocity will be 2.4 meters per second. For our observations, we saw that mass had no effect on the final velocity. The heavy and light car had the same velocity, and that initial and final velocities are equal. We found a calculated final velocity of 2.13 meters per second.
Trail 1, 3, 2, 1, go. Trail 2, 3, 2, 1, go. Trail 3, 3, 2, 1, go.
The distance on the ground from the table to the end of the ramp was 72 centimeters. The height of the track from the ground to the table was 74 centimeters, and the length of the track was 103 centimeters. Car number 1 had a mass of 45 grams, and car number 2 had a mass of 34 grams. The top position was 0.78 meters, and the bottom position was 0.492 meters. The height difference between the top and bottom was 0.296 meters. The predicted final velocity was 2.4 meters per second. The observed final velocity was 2.13 meters per second. The percent error between the predicted and observed final velocities was 12.7%. This can be seen in the graph where the blue dots represent the yellow car and the red dots represent the black car. Overall, this experiment revealed that acceleration, force, and mass are not considered when an object is moving down a curved ramp. Instead, the final velocities of the objects must be determined in the context of the conservation of energy, in which the initial and final potential and kinetic energies are equal to each other. Even though our hypothesis assumed that mass had an influence on the acceleration of the object and the force required to move the object, the formula used to calculate the final velocity excluded the object's mass. In this way, the final velocity takes into account the height difference between the top and bottom positions as well as the acceleration due to gravity. The predicted final velocity was the same for both the heavy and light toy cars, because they fall down the car track at the same height, and the observed final velocity was composed of horizontal and vertical velocities. In the end, then, we found that the predicted and observed final velocities had a low percent error, 12.7%, and the conservation of energy was demonstrated. Our original hypothesis was the mass of the toy cars would influence the final velocity, and the lighter car would have a greater velocity. However, the results indicated that mass has not effect on the final velocity, and due to the conservation of energy, the initial and final velocities are the same.